Velocity is the rate of change of displacement with respect to time. So let's look at a displacement time graph. We have displacement on the vertical axis and time on the horizontal axis. We know from previous work that the gradient on a displacement time graph will give us the velocity. So the gradient gives the velocity. Let's consider an ordinary set of x and y axes with a curve. The gradient function for a curve, which enables us to work out the gradient at any point on a curve, is called dy dx. Here, the gradient must therefore be dx dt, and as discussed, dx dt is going to be the velocity. So when we say that velocity is the rate of change of displacement with respect to time, what we mean is that v is equal to dx dt. Acceleration is the rate of change of velocity with respect to time. If we have a velocity time graph, then we know from earlier work that a gradient on a velocity time graph gives acceleration. So acceleration is given by gradient. From previous discussion, it should be clear that A is going to be dv dt. So to get acceleration, we differentiate velocity. A good way to remember this is if we have displacement, velocity, and acceleration, to go in this direction, we differentiate. Since we know integration is the reverse process, it follows that we should be able to integrate to go in this direction. You should remember this diagram.